Welcome to Sheridan College's Introduction to Instrumentation. This lesson is a part of Module 3, Temperature Instrumentation, and will focus on thermocouples. After completing this lesson, you should be able to explain some of the properties of dissimilar metal junctions, explain the Seebeck effect, explain how basic thermocouples work, and identify common thermocouple types. A thermocouple is a thermoelectrical device that uses the Seebeck effect and the Seebeck voltage derived from that effect to create a signal that is proportional to the heat exposed to the thermocouple's hot junction. A thermocouple works on two physical properties, on the differences in temperature and the reaction of the combination of dissimilar metals. When two dissimilar metals are joined together and not in an alloy, they can react to one another in different ways. Destructively, whereby the stronger metal will corrode the weaker metal; inertly, where no chemical reaction occurs, but the two metals will respond differently to exposures of heat, like bimetallic strips; and constructively, whereby the metals generate a small but discernible voltage, such as batteries and thermocouples. You have likely seen the destructive results of galvanic action, otherwise known as rust or corrosion. As electricians, we use anti-oxidization paste to prevent galvanic action. On the diagram, you will notice that the copper rivets are being eaten away by the wrought iron, and eventually it will fail. As we mentioned in an earlier lesson, all metals have different thermal expansion rates, and this is used to advantage in bimetallic strips. The bimetallic strips are used to open switches like thermostats, open motor overloads, and circuit breakers. They are also used to make robust and inexpensive thermometers. On the top picture, you'll see the same bimetallic strip exposed to heat and not heat. You can see the bimetallic deflecting. And on the bottom, that same deflection will act as a spiral to move the needle and tell you the temperature. When some metals come into contact, they can generate a voltage. The battery shown uses two dissimilar metals in contact with each other through an electrolyte. With thermocouples, a voltage is produced, but only when there is a difference in the temperature. The Seebeck effect is the reaction that some dissimilar metals will exhibit when joined together at each end and exposed to two different heat sources, whereby a current will flow between the two junctions at different temperatures. The voltage created by the Seebeck effect is called the Seebeck voltage. The Seebeck voltage is proportional to the difference in temperature between the two joints. In the diagram, there are two circuits. Each are connected at both ends. The top circuit is in thermal equilibrium, so no voltage is produced. The bottom circuit has a flame on one joint and cool vapors or ice on the other joint. This will produce a voltage. The voltage thus produced is directly proportional to the difference in the temperature between the two heat sources or joints. The greater the temperature difference, the greater the voltage produced. Thermocouples are electrical thermometers that take advantage of the Seebeck effect and voltage by using two dissimilar wires fused together at one end and left open at the other. The thermocouple shown is made of copper and an alloy called constant tan. Again, there are two junctions in our circuit. The red one will be exposed to a temperature source to be measured. This joint is called the hot or measuring junction. Be aware not to focus on the term hot. Think of it not as temperature, but as the source of the voltage, so it is hot as in live voltage. Or, to be safe, let's just call it the measuring junction. The blue junction is called the cold or reference junction. This will be opened later to connect a voltmeter. The reference junction is used to measure the voltage produced by the measuring junction due to any difference in temperature. Again, don't focus on the word cold strictly in terms of temperature. Let's apply some heat to the target material to be measured, say 90 degrees Celsius. The reference junction will remain at the ambient temperature of 25 degrees Celsius. As can be seen, a current caused by the Seebeck voltage begins to flow in the circuit. The Seebeck effect and voltage are named after Thomas Seebeck, who rediscovered the battery-like effect that heat had on some circuits with dissimilar metal conductors. Seebeck noticed that a compass needle deflected when two dissimilar metals were joined together at two different points, or junctions, and when one junction was exposed to more heat than the other. When the reference junction is opened, a voltmeter can be installed to monitor the voltage being generated by the differential heat between the reference and measuring junctions. If the target heat is lowered, cooling the measuring junction, the voltage will drop proportionally. If the measuring junction equals the reference junction, then thermal equilibrium will kill the voltage. The Seebeck voltage depends on two main factors: the two metals used in the thermocouple and the temperature differential between the measuring and reference junctions.